Yeah, good evening, everyone. So, in the last videos, we had very clear discussion about what are the various operations that we can able to perform on tree data structure and also binary trees. Now, in today's session, we need to talk with we need to talk about binary search tree. Okay, binary search tree. I want to talk about binary search tree, BST, binary search tree. First, let me talk about introduction to this binary search tree, and we will see in detail about this one. Sir, binary search tree is a special kind of tree, a special kind of tree, a special kind of binary tree with the following properties. What is the properties? Here the elements are the objects which are existed in the left subtree. Okay, in the left subtree of BST is less than root node. Okay, same principle we have to take for right subtree. The elements which are existed in the right subtree of binary search tree is greater than the root node, like this we have. Okay, so elements which are existed in the left subtree will be always lesser than the root node, and the elements which are existed in the right subtree should be always greater than root node. If we have any tree in this style, then I can say that the tree is nothing but binary search tree. Okay, that tree is nothing but what, sir? Binary search tree. Sir, I need to take some examples. For demonstrating this binary tree. Okay, because it is a very, very important tree what we have. Okay, and sir, what about the duplicates? Of course, in some books and all, you can take duplicates, no problem, but it is always recommended to take do not allow duplicates. No duplicate keys are allowed. Keys is allowed. That means, so with the same content, duplicate nodes is not possible. So I want to demonstrate with one small example, tree diagram. Let us see. Sir, I have a node is there called 3. Okay, so its left subtree is nothing but 1, like this I am taking. Okay, and its right subtree is nothing but I am going to take 7. Is it a binary search tree or not? Yes. First of all, it is a tree. Second, it is a binary tree. Then it is also binary search tree. Why? Because so 1 is nothing but left child of 3. If you see, this left subtree contains the elements which are lesser than the root node, that is nothing but 3, and the elements which are greater than this right node, so I mean greater than the root, should be available in the right side. This is one example. Sir, I want to take 4 here. Okay, and its left subtree is nothing but I am taking 2. So its left subtree is nothing but 1, and its right subtree is nothing but 3. So here I am going to take 6. Its left subtree is nothing but 5. Its right subtree is nothing but something like 7, like this I am taking. Sir, is it a binary tree? Yes, it is also binary search tree. Sir, how? If you take elements which are lesser than 4 are available in the left subtree, right? 2 is less than 4, 1 is less than 4, 3 is less than 4. And the elements which are greater than this one, like 6, it is greater than 4, 5 greater than 4, 7 greater than 4, like this we have. Sir, again internally it is a tree, right? Can you please cross check, is the left elements present in this second node, left elements to this second node, Is it having lesser values when compared with the root? Yes, 1 is less than 2 and 3 is greater than 2. Like this we have. And if you take this node, 5 is less than 6. Okay, so 7 is greater than 6. At the same time, please make sure this 5 and 7 should be greater than 4 also. Okay, and 1 and 3 should be less than 4. This property also it has to satisfy. Okay, of course, from this diagram you may get a small confusion, but in this binary tree and tree directly we added the elements, but in the binary search tree we will follow some principle. Based on that principle we will try to add the elements so that you people will get full-fledged clarity about this. Don't worry at all. Okay, this is nothing but what is mean by binary search tree, what we have. Okay, so I think no need to go for in detail. So you people got a clarity about this binary search tree. So if you are clear with this, I will implement a program for creation of a binary tree. Can you please confirm, is the concept is clear for you people, everyone? I request everyone to please respond. Clear up to this? Now I need to go for creation of binary trees. Creation of binary trees. So by using in order, okay, in order traversals, in order array. So maybe if you see in our binary trees, I have taken pre-order and then I constructed the tree. Okay, but here in order we are going to follow because it is easy. Once if the data is in order, then it is very easy to retrieve the data. I mean, to perform various operations, it will become very easy. Now, my requirement is, sir, I want to take one example first of all for demonstration purpose. Listen carefully. So here I'm going to take some notes. Okay, I'm going to take some notes like let it be. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sir, I want to construct a binary search tree for this. Okay. Yeah, binary search tree or binary tree. Binary search tree we are talking. Okay. Sir, what about the locations 0, 1, 2, 3, 4? Oh, here I have written binary tree. Oh, no, sorry. Binary search tree. Sorry. Hmm. Right. Yeah, sorry, sir. So now we have fifth location, sixth location, seventh location, eighth location, ninth location. Observe carefully how I am going to create this. Sir, first try to find out the middle element. Consider this is nothing but starting index. This is nothing but ending index. Try to calculate middle. So 0 plus 9, 0 plus 9, 9 by 2. Sir, what is the value that we are getting? 9 by 2 means what? 4. So the element which is located at fourth location will be the root node for this binary search tree. Excellent. Now I want to take left elements. These elements will comes under left side of this tree. These elements will comes under right side of this. So what are the left side elements? 1, 2, 3, 4. What about the indexes 0, 1, 2, 3? Again apply the same process. Now 0 plus 3, that is nothing but 3. 3 by 2 means we are going to get 1. So in first location, which element is there? That will become left subtree for this. Then this one will become another tree. This one will become another tree. Here 0 plus 0, 0, 0 by 2, 0. That will become root node. That is nothing but 1. For this, we don't have any children. And coming to 3, 4. So 2 plus 3, 5. So 5 by 2 means what? 2. Sir, 2. 3 will become left subtree. I mean right subtree for this 2. Then 4 will become right sub. Like this we have. Now for this 5, remaining order is there, right? Sir, what is the middle element? So 5 plus 9, which will become 14. 14 by 2 means what? 7. In 7th location, we have 8. So it is nothing but right subtree. Okay. So this is nothing but right subtree. This part got complete. Now 5 plus 6, which will become 11. 11 by 2 means almost it is a 5. Okay. 10 by 2, 5. In 5th location, what we have, that will become left subtree. Okay. Then 7 will become right subtree for this. So now similarly 8 plus 9. Okay. 17. 17 by 2 means what is the result here? 8. Yeah, 8. So in 8th location, what we have? 9. 9 will become right subtree. Then, so we have only one value that will be created at right subtree. This is nothing but binary search tree for these given elements. Sir, can you please try to take in order for this? Left subtree, root, right subtree. Left subtree is again a tree, left node 1. So then root node 2. Right subtree. Again, it is a tree. What is a left node? We don't have anything. Right node, so root node 3. Right node 4. So left part visited. So then root node 5. Right part. Again, it is a tree. Again, it is a tree. In this left subtree, so there is no left node. So root node will become 6. Right node will become 7. So left part completed. Root node is 8. Right part. Left part is not there. Root node is 9 and then 10. Are you seeing this is the same as this one, right? So if you are providing an array in order of elements, we can construct by using this low plus high by 2 mechanism for creating binary search tree. If you have an order, then we can create. Sir, I don't have this order, simply I have elements. Yes, possibility is there. That part in the next example I will explain. Can you please confirm? So what you can call diagrammatically how we are creating this binary search tree. Is it clear for you people? Clear? Right. Now I need to go for implementation of this one, sir. Let us see how we can able to implement this one. Okay, how we can able to implement this one, we will see now. Listen carefully. So here I am going to take, okay, here I am going to take a class called node, where it is going to take a data field, and the node left pointer will be there, node right pointer will be there. Then constructor I am taking, where I am going to take data. So current node data will become data. So current node left pointer will become null. Current node right pointer will become null. Like this we have. Then I'm going to take class BST, binary search tree. So node, I'm going to take root node. Whenever we are creating a new object for this binary search tree, our root node will become initially null. Now, what is our requirement? I need to create a binary search tree. So static, it will return a node where I'm going to call. So create binary search tree. Okay, create a binary search tree, otherwise create BST. Like this I will take. So where it is going to take one integer array called nodes, and then integer starting index, and then integer ending index. Like this it is going to take. Okay, like this it is going to take. Now what we have to do, how you can able to create this? So in the main method, first I'm creating for binary search tree. I'm creating object for binary search tree. and we have to create nodes. Your nodes will become, already we have taken, right, 1 2 3 4 5 6 7 8 9 and then 10, like this I am taking. Now obj dot your root node will become, so once if you call bst dot create binary search tree by passing this nodes comma 0th location and nodes dot length, so length -1. If you pass with this, it will create a binary search tree and it will return. So let me check that obj dot root node is there, right? It's a data I want to print. Sir, what output we are expecting? 5. 5 should be the answer. But let me see how this creation is going to takes place. So first I am going to take node is equal to initially null. If your start value is greater than end value, then I'm going to return that node. Okay. If a start value is greater than end value, I will return null. Otherwise, I will calculate middle value by taking the formula start plus end by 2. After that, I am going to create node is equal to, so new node of, so nodes of mid, with mid value, I am going to create a new node. After this node left pointer we have to assign. Again, I am going to call create BST by passing these nodes. Okay. And then starting location will be same. And for left subtree, how to divide that one? Up to mid -1 you have to consider. Similarly, that node right subtree is there, right? Again, I am calling BST by passing nodes and then mid plus 1. Mid plus 1 I am going to pass and then end value. Okay. These things we have to pass. And finally, we have to return node. Finally, we have to return node, like this we have. Now we will see how it is going to work. We will see how it is going to work. Now observe carefully. Suppose here, just for your understanding purpose, I am telling. So we have 1, 2, 3. So 4, 5, 6, 7. Like this we have. Locations 0, 1, 2. So 3, 4, 5, 6, 7, 8, 9. Like this we have. So now my first step is, sir, is the node is equal to null. First time it will create node is equal to null. What is the start value we have passed? 0. What is the end value we have passed? 9. Is my start value is greater than end value? No. Then mid is equal to start plus end. Mid value is equal to start plus end. 0 plus 9. 9 by 2. So your answer will become 4. So then nodes of 4, which element is there? 5th. With this element, a root node will be created. Of course, a node will be created. That's all. Okay. So now node dot left. Okay. Node dot left. It's a left child I am creating. Where I am passing, again create a binary search tree. Where nodes I am passing, starting value is 0. Ending value is mid -1. What is the mid we calculated? 4. 4 minus 1 means what? 3. That means these elements I am passing. Now what will be the result? First, is the start value is greater than end? No. Then mid is equal to start plus end by 2. 3 by 2. Sir, where we are going to get 1. So in first location, which element is there 2? With this, a subtree will be created, left subtree. Then again it is going to call same left subtree function, create BST nodes comma, what is the starting value? 0. What is the mid value? 1. 1 minus 1 means 0. So 0 plus 0, 0 by 2 means 0. In 0th location, which data is there? 1. With this, again a node will be created like this. Then again its left child will become create BST of nodes of starting value is 0. Ending value is what? Mid -1. Mid is 0. 0 minus 1 means 1. Sir, start value 0 is greater than -1. Yes. Then return null. So its left child will become null. So till now this part only we executed. One more part is there, right? Because recursion we called. One more part is there. Okay. You know very well in the merge sort I explained how it is going to take the values in the same style. So it will take mid plus one. Okay, mid plus one and then n. So here mid plus one will become, I think, somewhere where it is going to stop when we are calculating one. Here we stopped, right? No, here we calculated. So mid plus one, mid value is nothing but what? Zero. Zero plus one means one. And end value. Okay, what is the end value? I think when we are passing 0 comma mid plus one will become end value. So 1 is greater than 1. Condition is false. It will return null. Like this we have. In the same way, when we are executing this one, so we are going to get rest of the values. So what will become rest of the values for this 2? We are going to get nodes of mid plus 1. So where we got this mid value? At 1. So mid plus 1 means what? 1 plus 1, that is nothing but 2. Okay. End value will become what? In this case 3. Is the value is greater? No. So that means do these 2 3 I'm taking. So sum, if you take 5 by 2 means what? We are getting 2. So that means which element will become root element? 3. Then its left field will become as usual null, you know very well, and its right field will become 4. So for this again null, again null. Sir, we are getting these two values also, right? In the same way here in this process, 5 plus 9. Okay, 5 plus 9. So which will become 11, which will become, sorry, 14. Okay, 14 by 2, 7. In the seventh location, whatever we have, that will become left subtree. Then 5 plus 6. Okay, 5 plus 6. So which will become 11. 11 by 2 means 11 by 2 means almost 5. So 6 will become left subtree. Then 7 will become right subtree for this. And here 9 will become right subtree. For this 10 will become right subtree. Okay. Now, is it correct like my tree? Yes. So you can able to see here. Somewhere the problem. So 5 to 1. 5 to 1. Okay. 3 4 2 3 4 2 3 4. Okay. Next you can see 8 9 10. 8 9 10. So 6 7. So 6 7. Like this we are going to get. Perfect. But let me run this code. Really we are getting this one or not? How to get that? Sir, if you are, we are printing root node data. So our expected answer is nothing but what? We need to get 5. If we are getting 5, yes, our answer is nothing but correct. Let me check. I'm taking Java C space test.java. Sir, cannot find symbol variable obj. Yeah, here I need to declare obj. So Java space test. Sir, are we getting 5? What is its left child? 2, right? Now try to print object root is there. Its left child data. It should become 2. Then our explanation is correct. What is its right child? Right child. Let us take, it should be 8. Is it correct? Yes. So like this, we can create binary search tree by using this in order traversals. Once if you have any in order data, so then we can create a binary search tree in this style, sir. Can you please confirm everyone? Is the construction of a binary tree by using this in order style, is it clear for you people? Yes, requesting everyone to please respond. Clear up to this? Yes, sir. Two times I explained, sir. Again. Huh? Right. We will see another example if possible. Okay. Let me cover next scenario, then you will get. Flow of execution is nothing here. You can see. If you want, just I will repeat one more time. Please listen carefully. See, first we are going to pass the array, right? In that array, first element is nothing but a starting, last element is nothing but ending. I'm going to check is a start value is greater than end value. Whenever if you are getting like that, then we are crossing the limits. In such cases, there is no node in that position. In such cases, I want to return null. So is a start value is greater than end means null. Otherwise, we are calculating middle element. That middle element will become root node. Now what will be the element to the left side, sir? It is in order. So then all these elements will become left subtree because binary search tree property. The list is already in order. Compulsory if you take, so it will be in ascending order only. You can check any in order technique. So for binary search tree, definitely the elements will be arranged in ascending order only. That is one of the advantage here. So then we are calculating mid and we will make it as a root node. Divide and conquer policy. So now node dot left. This is the node which we created. It's a left node I want to create, which is nothing but again I am passing with the same details like starting comma mid minus one. That means excluding that node. Now what will happen with this? It will create a new tree. How we created binary search tree root node for this entire data, same process I am applying for this first half. So in this, which is the root 0 plus 3, sorry, 3 by 2 means we are going to get 1. In first location we have, this will become its root node. So this is nothing but another child. This is nothing but another pending. So this will become its left subtree. So right subtree, again 2 elements we have. Among these two, which will become root? 2 plus 3 by 2. So 5 by 2, which is nothing but 2. In second location, 3 is there. It is nothing but root node. The same process we are applying here also. So for that, these are the 3 steps. Node is equal to, I am creating a new node, which is nothing but I can say parent node. Its left child will become again the same process. Its right child will become again the same process. So when you don't have any elements like this, when you are crossing each other, start value, end value will become greater. In such cases, it will return null, which is nothing but last nodes. Clear? Like this we will have. Clear up to this? Okay. Until root is, I understood, but how it will go for right node? Sir, you didn't understand the flow of control for recursion. See, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is there. 0th location, first location, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Listen carefully. Start plus end. Start value is nothing but this one. End value is nothing but this one. So 0 plus 9 by 2. So 9 by 2, which is nothing but 2 4s are 8. 4. In fourth location, what node we have? 5. That will become root node. Listen carefully. So in this position, what is the starting value? 0. What is the ending value? Sir, we got 9. What is the mid value? So starting value. So your starting value is nothing but 0. Your ending value is nothing but 9. Your mid value is nothing but 9 by 2, which is nothing but 4. So that's why we got this element. Now listen carefully. So this is nothing but where I created node. Node dot left. I am passing start value as it is. S is equal to 0. I am passing mid value. I am passing mid value minus 1. What is the mid value? 4. 4 minus 1 means what? That will become end for next time. Because these are the values which we are passing to this. Nodes will become array unchanged. Start value, same value I'm passing, but end value got changed. Previously it was now 9. Now we are passing mid minus 1. 4 minus 1 means 3. One more method call is there for this. I am writing here itself. What is that left right mid call? Nodes of mid plus 1. What is a mid plus 1? 4 plus 1 means what? 5. Comma, your end value will become 9. This value is there already. Okay, this is for left, this is for right. Now for this, try to calculate mid. 0 plus 3, 3 by 2. We are going to get 1. So in 1, which node is there? 2. So it will become its left subtree. Okay. Now, sir, what will happen? For this again, since it is also a node, 2 childs will be there. One is nothing but left, another one is nothing but right. For left, what will happen? We have to pass a starting index. So what is the starting index here? Up to 1 it is divided. So what is the starting index here? 0. What is the ending index here? Which is nothing but mid minus 1. What is the mid value? 1. 1 minus 1 will become 0. So ending value. So mid value will become 0 plus 0 by 2 means we will get 0. So in 0th location, which element we have? 1. Similarly, for right, what will be the starting value? 0. Okay. So what will be the ending value? Mid plus 1. What is the mid value? Starting value will become, 1 minute, I am getting confused. Starting value will become mid plus 1. 1 plus 1 means 2. What is the ending value? We are going to get 3, right? Okay. So 2 plus 3, 5. So 5 by 2 means what? Your mid value will become 2. In second location, which element is there? 3. Like this, we got here 3. Okay. For this again, left, since it is also a node, left subtree will be there, right subtree will be there. For left subtree, what is the starting location? 0. What is the ending location? Mid minus 1. That is nothing but minus 1. Forget about mid. But here, this constraint is not satisfied, right? Start value is 0. End value is minus 1. Condition is true. It will return null. That's why its left node will become null. What about right node? Sir, starting value will become what? For right subtree, starting value will become mid plus 1. Mid value is 0. 0 plus 1 means 1. Ending value will become what? 0. So 1 is greater than 0. Condition true. That's why null. Are you getting my point clear? Ahmad, root left data. Root left is what? Hmm? Root left is what? Root, this is nothing but root. Its left is 2. Okay. Its left is nothing but 1. Its data is 1. We will get, if you want, you can see in the program, I will do that. You are going to get null pointer exception, man. Because the data is null, right? See, you are asking root node left. Okay. Its left data, right? So here root node is nothing but 5. Its left is nothing but, root node left is nothing but 5. It's sorry, 5, 2. 2 left node is nothing but 1. Its left node data you are asking. Okay. Sir, how many lefts you have given? Root left, to left, to left. I think you are going to get, so null pointer exception here. Okay. If I am correct, we are going to get null pointer exception. Have you observed why? Because this node is null. How you can apply data on this? Because it is a empty node, you can't ask for data. But if you remove one left, its value will become 1. That you can able to find out. Got it? Right. Sir, I think you people got full-fledged clarity about this one, sir. For every node, left and right recursion is doing, no, sir? Yes, correct. For every node, it is going to take recursion. I think you people are getting full-fledged clarity about recursion now, right? Right, sir. This is nothing but what we created, binary search tree for this. Okay. sir, fine, it is working good, no issue at all from this. But now my requirement is, I don't want this style. I don't want this style. I want to create my own nodes, because in our previous examples like binary tree, so there is no proper format. In any order you can store the values. That's why you can take in order or pre-order or post order or in order to construct binary trees. But binary search tree is not such a type of tree. You can give any element, you can insert that element by yourself, because the position you can able to identify. Very simple example. Suppose consider I have a node called 1. Now immediately I got one node called, assume it is a 4. I got one node called 1. You know where it will be created. Where, sir? Left to this node. Now I got 3. Where it will be created? So 4 less than this one, 1 less than this one means left subtree, greater than this one means here. Now I got 5 greater than this one. Now I got 9. Here it will be stored. Now I got 6 greater than 4, greater than 5, less than 9. So like this it will be created. So this technique I want to apply. So this is called as insertion. Okay, so insertion of a node into binary search tree. I want to insert a node into binary search tree. Sir, let us go for this one now. I want to insert node for binary search tree. Let us see how it will be. Okay, let us see how it will be. So I think this create BST is not required for me now. Now, sir, what is our next immediate data is, sir, I'm going to take, okay, I'm going to take here node, return type is node. I'm going to take, so otherwise return type is void. I will take void. So insert node I'm taking, where you have to provide some value, where you have to provide some value. Sir, that I'm going to assign to root. So your root will become, so insert node of, where we have to insert, sir, we need to insert at, okay, we need to insert at root. To the root you have to insert this value. Okay, value, or you can take data. Better to take data to avoid confusion. Like this we have. Sir, again I need to write insert function. Okay, node insert node, it is overloaded method, where it is going to take some node and then integer data. Sir, why you are not calling this one directly? Because return type is the biggest problem here. So here simply I am taking obj, simply I am taking obj, and directly I will call like this, obj dot, can you please insert the node called 2? Obj dot, can you please insert the node called 1? So obj dot, can you please call insert node of 3? So can you please insert the node called 4? Like this we can call. Now, if you print, so what I am going to print here, better I will print in order traversal, obj dot, so in order, okay, in order traversal of obj dot root node I will pass. Okay, obj dot root node I am passing. Sir, physically, if you see, first we are trying to insert 2, that will become root node. Next node is 1. So here we are going to get like this. Sir, next node is 3. Compare with root node. Is it less than or greater than? Greater than. Go to right subtree. Insert 4. Compare with root. Less than or greater than? Greater than. So go to 3. Is it less than 3 or greater than 3? Greater than 3. What is the in order for this? Sir, first LDR, left subtree 1. Root node 2. Left subtree. Again it is a tree. What is the left for this? No. Then root node will become 3. Right subtree will become 4. So we are expecting, so 1, 2, 3, 4 for this. Okay. So we know the code for this traversal, right? In order traversal. How it will be? Void I am taking. So in order. Already we discussed this in the last video. If node is equal to null, then we are going to return empty. Sir, else again we are going to call in order of node dot left, and then system dot out dot print of So we are printing node dot data plus followed by some space. Then I'm going to take in order of, so node dot write I'm going to take. Like this we have. Beyond that, nothing is there. Okay, beyond that, nothing is there. Now we will see how to insert the node, because all these things we discussed already. Sir, how to insert the node? Boss, can you please check, is your root node is null? Or if your node is equal to null? That means what? First time we are creating this node. If your node is equal to null, then node is equal to, I am creating a new node with the data whatever you have given. Suppose if node is not equal to null, then what will happen? Sir, please check the node's data. That means node is not there. So that means node is there. That means what? It's a data I am comparing with the data which you have given. If it is greater than, that means my node data is greater when compared with your data. Means what? Your data is less. Your data is less. Otherwise, you can write like this. So data is less than node dot data. Then where we have to insert this left part, right? So node dot left will become, sir, again I am calling insert node by passing, okay, by passing node dot left and then data else. So definitely it will be greater. If it is greater, node dot right will become, so insert node of node dot right comma data we are passing. That's all. Beyond that, nothing is there. Okay. Beyond that, nothing is there. And at last, we have to return node. Sir, I will explain this process. Don't worry at all. So what is the order that I need to create? So 2, 1, 3, 4. Listen carefully. First, I am inserting 2. Sir, consider this is my tree. This is my tree. As of now, tree is not there. Okay. As of now, my tree is not there. What will happen? Sir, node is equal to null. Yes, because insert node, we are passing 2. Insert node of to the root, we have to insert this data. Root is equal to. Okay. Insert node, I am passing root, right? Is there any root here? No. If node is equal to null, then it will create a new node with given data. What is the data that you have given? 2. So with this if condition completed, it will return that node that will be assigned to root. Now I am inserting 1. So insert node for root, we have to insert 1. Sir, what is the node? Is node is equal to null? No, because node is root. It is not null. Then what will happen? Sir, if data is what? 1 is less than root node data. That is node is nothing but now root. Sir, is it less than 2? Yes. Then listen carefully. Node dot left. Previously it is root. Now node dot left is equal to insert node for node dot left comma data. What is a node dot left? Initially null, right? If node is equal to null, that means node dot left I am passing. It will become node. Is node is equal to null? Yes. Then create a new node with the data. What is the data that we have given? 1. So this if condition completed, it returned that node completed. Now I am inserting 3. Now listen my words carefully. So is node is equal to null. First time what is a node? Root node. This will become node now. Okay. Sir, is it equal to null? No. Then check the data. What is your data? 3. Is it less than node data data? Node means root node. So is it less than root node data? No. Condition not satisfied. Then go to right part. Node dot write. Node dot write means this one. Node dot write. Sir, is there any node here? No. Insert node of node dot write comma data. It will be passed here. Now this is not your node. This is your node. Is node is there? No. Then node is equal to new node of with the data 3. Perfect. So return that node. That's all. Now I want to insert 4. Now listen carefully. Sir, your node is nothing but 4. I want to insert for root. So I will check, is node is equal to null? Root is equal to null? No. Then data. What is the data that you have given 4? Is it less than node dot data? No. Then go to right. Then go to right. Okay. So what is the right here? We have node dot right. Node dot right means this will become node dot right. Listen carefully. This will become node dot write. I will erase this. So previously this is node. Now I will change the color. Sir, now this is the node initially. Okay. Sir, is it equal to null? No. What is the data that we have given? 4. Is it less than node dot data? No. Then going to write node dot write, insert node of node dot write comma data. Now it is calling node dot data. Now what is the value of node? This is not node now. This is the node now. Okay, it is nothing but this one. Sir, is it equal to null? No. Sir, what is the data that you are giving? 4. Is it less than node dot data? 3. So condition not satisfied. Go to write node dot write. This is the node dot write. Okay. Sir, insert node dot write. Now I am passing this. Now what will be the value of node dot write, which is nothing but null. Okay, which is nothing but null. Sir, now is node is equal to null? Yes. Create a new data with content 4 and return that node. That's all. So this is the way how binary search tree nodes are going to be created. Can you please confirm, is the physical representation is clear for you people? Yes. I request everyone to please respond. Right. Let's execute this. Really, whether we are getting this in order or not, we need to check. 1, 2, 3, 4. Perfectly working. So this is nothing but example number 1 for insertion of a node into binary tree. I will take one more example. First, I will take a diagram. Later, we can go for. Sir, I want to insert nodes like so 6 and then 4 and then 2 and then 5 and then 1 and then 3 and then 8 and then 7 and then 9 and then 10. So in order, first I am going to take 6. So create. I am not using arrays concept. I am using normal insertion. Then I want to insert 4. So left, in the left it is going to insert. What if we take duplicate value? That's what in the beginning itself I told. We should not take duplicates. If you are trying to take duplicate, you have to frame the condition related to that. Less than or equal to something like this we have to do. Okay. But never recommended. Now. So see here. So where this 4 will be inserted? Left part. Now I am taking 2. Sir, less than root. Less than left subtree. So 2. Then 5. So less than root node, greater than right subtree. Take 1. Less than root node, less than left subtree, less than left subtree to left subtree. That means here. Now 3. Less than root node, less than left subtree, greater than this subtree. So 3. 8. Greater than right subtree. 7. Greater than root node, less than left subtree. 9. Greater than root node, greater than right subtree. 10. Greater than root node, greater than right subtree, greater than right subtree. What is the in order for this? So root node, again we have left subtree, again we have left subtree. So 1, 2 and then 3. So left subtree completed, root node is 4 and then 5. So total left subtree completed, root node is 6, right subtree. Again, we need to take left subtree since we don't have left and right, and 7 we have to take, 8 we have to take. And this one, left subtree is not there, 9 and then 10. So order from 1 to 10 we have to get. Now try to insert this. So what is the first node that we are going to insert? I think 6, then 4, 2, then 4, 2. So next we have to insert 5, 1, 3. So 5, 1 and then 3. So next I need to insert 8, 7, 9, 10. So 8, 7, 9, 10. So what is the order that I'm expecting? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think so. Let's run the code. Is it coming or not? Perfectly coming. This is the way creation. Sir, creation is very easy because internally it is assigned with some algorithm, that is binary search algorithm. That's why just we have to check level by level its position, and we have to insert. But deletion is a difficult task that we will see with examples. Multiple cases will be there in that. Okay. Can you please confirm everyone? Is this binary search tree insertion of a node into this binary search tree? Is it clear for everyone? Right. Right, sir. So thank you. That's all about today's session. Tomorrow, sir, tomorrow I'm going to take the class. Okay, tomorrow 7 to 8 o'clock I'm going to take the class, maybe up to 8 or 8:30 like that. So I'm going to cover any one of these topics tomorrow, like either greedy algorithms or divide and conquer, okay, or backtracking or dynamic programming. So among these four, I want to take any one topic. Okay, any one topic. So tomorrow I am going to take the session. Okay. As usual, same link at 7 o'clock. Right. Thank you guys. See you tomorrow. Good night. Yeah, I will upload the notes, sir. Don't worry.